Okay, so in the last video we looked at solving problems with Ohm's law. That's our V equals IR equation. And we also looked at the different factors that affect electrical resistance of a wire, namely the length and the thickness of the wire. So this video is going to be shorter. All we're talking about is electrical power in this video, and then you're going to have a practice worksheet to work on with basic calculations. So let's talk about electrical power. Let me make this a little bit bigger so you can see. Okay, so any device that's plugged into any type of electrical circuit uses up energy from that circuit. Okay, whether it's a resistor, whether it's a light bulb, a light socket, whether it's your phone as it's charging, it has to have some way to use energy up to get energy from the circuit, from the voltage source. And so this is what we call power dissipation, or you could just say power. Dissipation basically means used up. Okay, so when we talk about power dissipation, you're talking about some devices using up power from the electrical circuit. Now, we've talked about power before. Just to remind you, the symbol for power is a capital P for power. The unit for power is watts with a capital W. And that 1 watt represents 1 joule per second. And remember, joule is the unit for energy. Okay, so something with a power dissipation of 1 watt is basically using up 1 joule of energy every second. Now, typically when you're talking about electrical devices, you can find the power usage either on the back or on a chart that you can look up online. Now, the reason power usage is important, if you're thinking like, practically speaking, power usage is what you pay for when you pay your electric bill. Now, we're not going to get into how your electric bill works because it's kind of weird with the units and everything. But basically, when you pay your electric bill every month, when you're an adult and you have to pay your electric bill, what you are actually paying on is basically how much energy you used throughout the month, which is based off of the wattage or the power used by each of your devices multiplied by the time that you use that device for. Okay, so for example, let me just erase this and go to the next slide. Okay, here's a chart that has just a very few different common devices you might see along with your power rating. Your refrigerator maybe has a power rating of 50 watts. It could be more, it could be less. That's just a rough estimate. Your freezer probably uses more power than that to keep things cold, maybe 300 watts. Your washing machine, maybe 500 watts. Dishwasher, maybe 1300. Your TV could use a couple hundred. Your computer could use, I don't know, a couple hundred watts. And all of those things add up. And again, power, just go back to the last slide, power is watts, is measured in watts, which is joules per second. And so when this says the freezer uses 300 watts of power, that basically means that every second it uses a lot of energy. Okay, so 300 watts would be 300 joules per second. And then, at the end of the month, you would multiply that 300 watts by how many seconds did you use your freezer throughout the month. Well, usually your freezer is on almost all the time. And so when you multiply that 300 watts from your freezer multiplied by how many seconds there are in the month, that gives you a number in joules of energy. And that's basically what you're paying on your electric bill. And you have to do that for all of your devices. They basically all come added together, measured by your electrical meter. And so that's why power rating is important. Now, again, if you look at the device, on the back of the device, either on the plug or on the back, a lot of the time you can find information about the voltage or about the current or about the wattage on the back. For example, this is the back of a computer case, and you can see right here it says 390W max. That means a maximum of 390 watts of power based off of the power supply in this device, and it's meant to work with between 100 to 240 volts of voltage. Okay, so next time you're looking at your phone charger or an AC adapter, some random electrical appliance, see if you can find the wattage. It's typically listed somewhere on the back by the plug. Now, of course, we talked about what electrical power is and why it's important, but you also need to know how to do calculations with electrical power. Now there's 3 equations for electrical power, and they're all based off of things we've talked about before. So remember, we have our Ohm's law that relates voltage to current and electrical resistance. Okay, V equals IR. Now for power, we have 3 different equations for power. We have P equals IV, we have P equals I squared times R, and we have P equals V squared over R. Okay, and they're all perfectly valid. They all have the unit of watt, and you can use whichever one you want as long as you have all those variables. And so that means if you're doing a problem and you're trying to figure out, which equation for power should I use, you should use the equation that has all of the variables you're given. If you're given current and voltage, then you should probably use the equation for power that has current and voltage. Okay, and so these equations are all the same. There shouldn't be a mystery about which one you should use usually, because usually you're only given 2 variables, and so you can only use the power equation that has those 2 other variables. And we'll see that in the examples that we're going to be doing. Okay, so basically we have 4 equations up to this point. We have Ohm's law, V equals IR, and then we have 1, 2, 3 equations for power that we're going to be doing problems with. Okay, so make sure you jot those down because we're going to be referring back to them on your worksheet. I will supply you with those equations, but for now, just jot them down because I'll be using them in just a minute. Okay, now just to kind of summarize everything we've talked about before and give you some reminders, these are the 4 quantities we've talked about up to this point. We've talked about electric current, voltage, resistance, and power. This is the symbol for each of those. Remember, current is a capital I, voltage is a capital V, resistance is a capital R, and then power is a capital P. And then we have the units and the unit symbols for each of those. Remember, current is measured in amperes with a capital A, voltage is measured in volts with a capital V. The unit for resistance is the ohm, which is that uppercase omega, that horseshoe looking thing. And then of course power is measured in watts with a capital W. And these are all capitalized because they're all named after people. Okay, so now we're just going to do some basic calculation examples, and then after that you'll have a practice worksheet to work on. Okay, so example 4. It says a 60. Now remember, W is watts, and so the first thing you should realize is 60 watts, that must be the power, based off of the unit, that must be the power of the device. So we have a 60 watt light bulb, meaning the light bulb uses 60 joules of energy per second, and it's plugged into a wall socket that has a voltage. Okay, so this is going to be our voltage of 120 volts. Now, the first question says calculate the current that flows through this light bulb. So, just like any problem, we start by writing down our given, 60 watts. We have a voltage of 120 volts. And so we're looking at our 4 equations to figure out which equation has P, V, and our missing, our unknown, is current, which is I. Okay, so which equation has P, I, and V? That would be our first equation for power, P equals IV. And so all we're going to do here is plug in. P is 60, I is unknown, V is 120. And so to get I by itself, I have 60 equals I times 120. So I'm going to divide both sides by 120. So I is going to be 60 over 120, which is going to be 0.5 amperes. Okay, so the current going through the light bulb is 0.5 amperes, just like that. Okay, very basic calculation. Now the second part of example 4 now says calculate the resistance of the light bulb. So now we want to use an equation that has R. Now in these 2-step problems, now that we have P, I, and V, we can use any equation we want as long as it has R in it. Okay, so what I'm going to do is I'm going to use Ohm's law, V equals IR, but we could use one of the other power equations that has resistance in it as well. I'm just going to use this one just because it's a little easier. I know V is 120. I know I is 0.5 because I found that in the last problem, so 0.5 times R. I'm multiplying here, so I want to divide both sides by 0.5. So R is going to be 120 over 0.5, which is 240. And remember, the unit for resistance is the ohm, which has a symbol of that horseshoe-looking thing, that capital Omega. Okay, so this is my answer to the second question for example 4. Okay, so the simple calculation problem with Ohm's law and power equations. Okay, so we're going to do at least one more. Pause it here if you need to look at that again. Okay. Example 5. It says a simple circuit is created as shown to the right. So take a look at the picture to the right. We have, let's see, a battery, and it says 9V, so 9 volts. That's your voltage source. And then it says we have a resistor, which remember is just some device that uses up power in our circuit. And it says 100 ohms, so that's going to be our resistance. Now the first question says calculate the power that will be dissipated, that means used up, by this resistor. Okay, so again, start with identifying your givens. We have V equals 9 volts, R equals 100 ohms. And so if we want to find power, we need to use an equation for power that has V and R in it. Okay, so if you look at your list of equations, it's the equation that looks like this. P equals V squared divided by R. Okay, we can't use one of the other equations because we don't have current, not yet. So P equals V squared over R. I'm just going to plug in my givens. V is 9, so 9 squared divided by R, which is 100. And if you put that into the calculator, you get P equals 0.81 watts. Remember, power is measured in watts. It's joules per second. Okay, so that means this device plugged up to this battery is going to use 0.81 watts of power. Okay, that's the power that's going to be dissipated or used up. Now the second question says calculate the current that will flow in the circuit. So again, we have a two-step problem. Now that we have power, I can use any equation I want to find the current. I'm just going to go back to V equals IR, my Ohm's law equation, just because I think that might be easier. Okay, so V equals I times R. I want to find the current, which is I. So I have 9 equals I times R, which is 100. I'm multiplying I by 100, so I want to divide both sides by 100. I equals 9 over 100, which is 0.09 amps, or amperes. Okay, so that is my answer to the second question for example 5. Okay, so again, pause it here if you need to look over that. Okay, so I'm going to erase this. Okay, now I want you to try to do this one on your own. Okay, so pause it here and try to see if you can answer both of these questions on your own. Question 1, what is the voltage of the battery? And then question 2 says, how much heat is the resistor creating per second? Remember, energy per second is power, so the second question is asking you about the power dissipated by the resistor. Okay, so see if you can answer those two questions. Pause it here, and then I'll put the correct answer up in just a second. Okay, so I'm just going to do this really quickly. This is R, this is I, voltage is V, so V equals I times R. Is going to be 2 times 5, which is 10 volts. This question is asking me about power, and I'm going to use the equation that has I and R because that's what I'm given, so P equals I squared times R. So that's going to be 2 squared times 5. 2 squared is 4, so 4 times 5 is 20 watts. Okay, so hopefully you got 10 volts and 20 watts for those two questions. Okay, so pause there. Check those answers with the ones you got. Hopefully you got those correct. Okay. And then just to summarize basically everything we've learned up to this point, this is what we've covered since the start of the unit, the essential elements of a circuit. We talked about current, voltage, Ohm's law, what resistance is, the factors that affect resistance, and then power and doing calculations with power. Okay, so at this point, we're at the part in this unit where we can work on a simple worksheet. As always, please let me know if you have any questions about this video or about the worksheet. And I will see you in the next video.